I've been fielding a handful of emails from some customers who were asking some questions about visualization, some really specific, some really general. But one thing we're getting quite a bit of is how do I get my data out of 3DCS and how do I get it into my visualization tool with as much of the content from 3DCS transferring over. Depending on what kind of visualization package you're going to, some accept more of our data as far as the material or the part name, and others might not accept nearly as much. Last webinar that we did, we really keyed in on our integrated visualization exporter and going into DeltaGen and how that whole workflow goes. So we'll touch on that briefly. But what we're really going to touch on today is going into some other CAD packages, some other visualization packages, and how we can get that data out. So what we have here is we have a car model that was built up in 3DCS. We have a handful of spec studies that are already built. Some of you might be familiar with this vehicle. We've used this a couple of times to kind of showcase this. So a couple of software packages Ben did touch on were obviously CATIA products, live rendering built into V6, which is outstanding, DeltaGen, which we keyed on last time and we'll talk about again today, but also some visualization tools that you might not have heard of. VRED. VRED is another very high-end visualization tool, much along the same lines as a DeltaGen. Showcase is kind of a step down, still very high-end visualization tool, also made by Autodesk, and it would do the job for probably 80% of the people, maybe 90% of the people who are using it strictly for visualization. So I'm going to talk about these two, VRED and Showcase, both by Autodesk, and how we can get data out and into those tool sets, and what are some of the kind of workarounds, or what are we going to kind of be up against. So as we did last time, we used a visualization exporter that we've used before, which is our push-button visualization exporter. That works with the importer for DeltaGen. So what we're going to talk about today is more of a manual workflow. How can I get my parts out? And we're not going to be touching on too much of the automated process using the visualization exporter. So we have our spec studies already built up here. We have the full car sitting in a nominal position. So the first thing that we're going to want to do with this vehicle is we're going to want to, in a nominal position again, we're going to want to export a graphics file. What we're going to do here is we're going to export out an FBX model. An FBX, as we talked about in the last presentation, is kind of a universal geometry export that can be brought into just about any tool, kind of a universal tool. So we would go ahead and we would export out. I always kind of work locally. I would export out this whole vehicle in a nominal set. And that's if you want to do a visualization of the whole vehicle and your spec studies and how they affect that whole vehicle. I wouldn't suggest this approach if you're only going to be like looking at the hood to the fender to the fascia to the headlamp, let's say. We don't need to export out the complete interior of the car or tail lights or anything that's going to be a heavy geometry set. So to export out the complete nominal full car, we would export out by file name and FBX and click Save. It's going to take a little while. Some of these files can go upwards of maybe 500 to, I've seen them go all the way up to a couple of gig files. So they're going to be big files for a nominal. And again, this is not suggested if you're just going to be looking at a specific area for the study. After we've exported out our nominal geometry, the way that we get out our spec studies and the affected geometry would be to, if I want to just take this hood and export this out in a spec study deviated position, I'm going to go ahead and I'm going to branch the tree in 3DCS. So all I'm looking now is at this hood. Now when we go to export out, all it's going to export out is the actual geometry for the hood in whatever deviated position we've set. The reason for this is that if we go back to our complete car, If I go out and I just select this one piece of geometry thinking I'm going to export out only the hood, it's going to export out the complete vehicle set again with a hood in a deviated position. So you're going to end up with an extremely large file. So what we do is we always export out a complete nominal set, and then we only export out the parts that are going to be in a deviated position. There's a couple of reasons here. It gives you a lot of control over what you want to show and how you want to work in your visualization tool. Me personally, I'll bring in my nominal set and then I completely shut it off once I've brought in my other geometry and verified that it's in a correct position. Now I'm not loading my system trying to orbit or rotate or put shadows on a complete nominal set of geometry until I'm ready to make final images. So with this piece here, when we go into VRED and Showcase specifically,
Autodesk products?
These are the Autodesk products, correct. It's going to get its color. Right now I have this hood painted white, but it's actually going to get its exported color from this, from the actual part color. So it's not the color that you actually see in your model right now. It would be the default color for this part. So this part will actually import into VRED and Showcase as a blue hood, not a white hood. The material name itself is going to be the part name, not a material name. Even though if I open up my styles and I have a blue paint, it will not export out the name paint blue. It's going to export out the part number as the material name. So as long as you kind of get that workflow together, understand that little quirk, the rest of it is pretty seamless. I'm going to go back and branch into my complete model here. And now if I wanted to export out just the fender itself, I go ahead and I center the graph, I find my fender, and again, I branch out into just having that one part. Now when I export, it's going to export out whatever is shown, which is only the one part that we've branched into. The other way of going about this, and it's a little more of a workflow, let me get back to my models, is to stay in your nominal set and hide off everything other than what you want exported. So I could hide off the complete car, every other piece, and just leave the hood and the fender in a deviated position and export out those two together as one set. The thing that you're going to lose is you're going to lose control over those two individual pieces as individual pieces. They're going to come in as one data set, the hood and the fender tied together. So those are some of the little quirks with, and they're really not even quirks. It's a workflow. It's a pipeline of how we get our data out of 3DCS and into other visualization tools. Once we're into our other visualization tools, there's some terminology, whether it be a variant, whether it be a style set, or an alternative. But what I would do is I would take the hood and the fender that build up one spec study and make a variant of those, or an alternative of those. That gives me the control to, when I'm in my visualization tool, to go through and show just specific spec studies by shutting off the other variants. So I might have a variant called hood to fender max gap. That's going to be one variant. Now I'm going to have hood to fender min gap. That will be another variant. Those two will never be shown together because the geometry would overlay on top of each other almost. So you would turn one off to turn another one on. That's how we would show spec studies in a VRED or a Showcase. Again, the material names for this are going to come through as a part name. The other thing that we touched on the last time was the importance of camera and setting up camera views within 3DCS. The camera views in VRED, Showcase, DeltaGen, KeyShot will all import. So they're going to import as separate cameras the same way that we have separate cameras in 3DCS. So the advantage is now I don't have to try and match a camera view that I had in 3DCS to a camera view in a key shot or a delta gen or VRED. They're already there pre-set up.
Can you show us those?
Absolutely.
Where are they in the tree?
Yep. So we talked about this last time about kind of easily building up some views. I have a whole bunch of views here, and some of these are just to look at certain areas. Some are also tied to spec studies. So if I double click on my ISO front, there's my ISO front. Now when I export out, it's going to ask me if I want to bring my camera views in that are tied to this specific spec study. You would say yes. And that way, the exact same camera view, focal length, everything is going to match from our software into your visualization tool. If there's any questions that would be specific to a VRED or a showcase, just let me know so that I kind of know the tool set that you're talking about. So that's kind of the manual workflow that we would use for getting spec studies and the spec study geometry out of 3DCS into an Autodesk product such as VRED or Showcase. The one thing that I will make sure to tell you is no matter what visualization tool you're going into, to make sure that your scale is correct, that the scale that your model is in 3DCS is the same scale that your model is in visualization, because that's going to affect shadows, it's going to affect ambient occlusion. If your model is scaled up, let's say 1,000 times, it's going to look different. Whether it visually looks different on your screen or not, the actual interaction would be different. So now I'm going to start to talk about KeyShot. KeyShot is another very good, quick visualization tool. It puts out an excellent image, but it is not made to come back to a visualization job and rework it over and over. Once you kind of start a KeyShot project, once you're done with it, that's as far as it really goes. You would never kind of continually add back into it and be cranking out images. So KeyShot's used a lot in studios and product design and automotive design. Very easy tool to learn. Learning curve is very low. Some of the things that we need to understand when we're working with our data and getting it into KeyShot. Same thing, setting up variants for all of your spec studies. They're called variants in KeyShot. Other software, they might be called something different. When you're importing your data in, you have an option in KeyShot, and some of these other software too, is to keep the coordinate system of all the parts, which they're going to be imported then in the exact same location and coordinate system as they were in 3DCS. That would be called keeping the original in KeyShot. Otherwise, each part, as you import those in, are going to be put to the center and put to the ground. So they won't be in the actual vehicle position or product position. They will be in a 0 position. So that's one thing to remember.
So if they come in a 0 position, you just have to reset them to their existing position?
I would actually delete them back out, re-import them in, and then click the box that says Keep Original. What you never want to do is, I never want to be responsible for moving a customer's geometry into a set position, because now if it doesn't look right, it's not them that moved that geometry, it's myself that moved that geometry, and I might have been incorrect in the movement. So with KeyShot, the other thing is we retain that part color that was in the tree, and also the parts come in, the materials will be per part. So if I bring in the fender and the fender is red, it's going to have its own material. Even though the hood may share that same material, when it is brought into KeyShot, it's going to be brought in as 2 separate materials. The hood part name and the fender part name will both have a separate material. Some of the ways around kind of organizing your file would be to go into your tree, grouping all of your, let's say, outside body panels that will share the same color, group them together, then add your material to that group top node, and that way it'll paint all your panels the exact same color instead of going in individually and painting each part an individual color. So if you have any questions about that, feel free to email me and I can kind of walk you through it. It's pretty simple once you do it the first time.
That's creating like a sub-assembly.
It's creating a sub-assembly, right, that would that you could then drop all your parts that share the same material color. That way, if I go to change the car from a white to a blue, I only have to drop that material one time. I don't have to drop it on every individual panel that shares that same color. So with KeyShot, again, two of the biggest things I would say to keep in mind is making sure that when you import your geometry, you're importing it in using the original coordinate set. And that's, again, called keeping the original within KeyShot, and knowing kind of how the materials are going to work and how they're going to be tied to a part name and not an actual material name. Once you're in KeyShot, we can go ahead and change all that so it's organized a little bit better. But upon import, that just kind of needs to be noted. And then we go to DeltaGen. DeltaGen, the great thing about this is that we have built an exporter that ties into an importer on the DeltaGen side, which needs to be purchased separately. It does a fantastic job of bringing in our data, keeping all of our spec studies and our simulation studies. All these are already brought in. So we don't need to bring in the hood and the fender 5 different times to show them in 5 different positions. When we use the importer, it's drawn in our XML file, which has all the parts in their translated positions for the spec studies. So this is really a ease of use or a speed of use of the product and exporting out our geometry and our spec studies and then bringing them in. As I said last time, some of the other things that are really nice in the DeltaGen plugin is being able to use something that's called a look assignment table. So what this does is this will then say our target look name is whatever that material is. Let's say here it's white paint, and we call it white paint when we export out. If we associate a DeltaGen material to that, now every time I import something in that says white paint, it will then automatically assign a DeltaGen material that says white paint. So now you're not having to, as you bring in multiple renditions of a spec study, you're not having to repaint them every time. It's a little bit of time to set up, but for your workflow from then on, it's a huge time saver. Regularly use it.
Now, my materials in 3DCS, if I've named them the same as they are in DeltaGen, will they convert automatically?
No, because you have to initiate that tie of saying this material is associated with this DeltaGen material.
Gotcha.
So even if you name it correctly and you try and name it the exact DeltaGen name for that white paint, it still doesn't know that your associated paint is associated with DeltaGen's white paint. So you just have to kind of build that bridge together. Once it's done, it's a huge time saver. So last time we really went heavy on DeltaGen. I'm not going to go too heavy on it this time. I really kind of wanted to talk about some of the questions I was getting about a manual workflow and getting my data, into a different visualization tool. So again, if anybody has any questions that you kind of come up with after this, Ben has my email, and I think it's in the presentation. Feel free to email me. I'll help kind of walk you through it. I was getting a lot of VRED questions from the last presentation, so I tried to address those here very specifically to some of the questions that I was getting.
Great. All right, well, thank you, Scott. So we're at 50 minutes past the hour now, so we have a couple minutes for questions in case you want to send in additional questions. We try to get to most of them throughout the presentation so that we wouldn't have too many set aside for the end here. See here if we...
And there was one other thing that I kind of wanted to show that I didn't touch on here. So what I did here was just shot a couple of images of the way that I use my workflow, whether it be going into any one of the various tool sets for visualization. What this shows is this is just my hood and my fender export. This is after I've already exported out my complete car. So I verified that, yep, the parts are coming in the correct position. I've verified that the coordinate system is correct, even though obviously it's shown on the floor here. So then what I do is I will color each spec study initially a specific color. So here I have a nominal hood in yellow, and my fender might be in a deviated position. So all of my nominal geometry, I have a variant set that says, okay, paint all nominal geometry yellow. It just makes the workflow for me much quicker to be able to build my variants, know what parts are associated with what spec study. So now I have the nominal hood shown in yellow that you can see with a deviated hood in a maximum position. What this does for me is I verify that, yes, my deviated hood came in a deviated position because I reference it back to nominal. The other one here is the influence sphere, where we kind of smile or warp the hood. So I've changed that to a red. And then I overlay all three together to know that no three are encompassing the exact same space, meaning that I've duplicated, let's say, a nominal hood, and yet I'm calling it a maximum deviated hood. So this shows me that, yes, I've brought in all my geometry, it's all in its deviated position, and it's correctly, now I can move forward. Instead of finding this out much later on in your visualization work, and then you have to go in and replace things.
So you're using this as a check and validation tool for the modeler, right?
I'm using this exactly for a check and validation tool for a modeler and for myself before I start spending, the amount of time that I do on visualization.
This can also be useful too, because as you can see, Scott's color-coded the different outputs. So, the minimum, the maximum, or the influence sphere here have been given different colors. So I can line them up, and I can see the yellow, which is my minimum condition.
The yellow is actually nominal.
So I can tell my nominal from my maximum condition, and I can see how they differentiate from each other. So it's a nice way to compare nominal to a deviated position at the same time, so you can kind of call out that difference.
Exactly. And obviously these views can be, these were camera views that I set up, sorry about that. But I mean, you're able to go in and zoom into your model and make sure that the geometry that you're showing and that you're going to show typically to a high executive level is the correct geometry. You don't want to go in there without the correct geometry. Obviously, you're in the wrong position.
So it's nice to have a quick check as you're moving forward before you spend all of the time.
Absolutely.
Great. Actually, I just got notified from one of our partners at Dassault Systems that in 10 days' time in Milano, Italy, that there'll be another event where they'll be presenting the perceived quality presentation.
Fantastic.
In 3D Experience CATIA V6. It's called The Design and the Age of Experience. It's the name of the event. It's the 11th to 12th of April in the Michael Congress Center in Milano, Italy. And it's actually a free event with roundtables, breakout sessions, and demo pods. So it's really hands-on. I'm usually not one to do too many plugs here, but because it is a free event, it's a really good chance to see what CATIA V6, what Dassault Systems are doing in regards to perceived quality. So if you're anywhere near, Milano, Italy, during the middle of April, this would be a really good event to stop in at, even if it's only for 1 to 2 days.
Absolutely. If you haven't seen the live rendering or what Dassault has done with V6 as far as rendering goes, it's definitely worth looking into.
Absolutely. So I really appreciate that, letting me know about that event. I'm going to just put a little information about that and some of the upcoming events we have and the email that you receive after this. And like I said, you'll have access to the white paper that's based off the presentation that was done last November at the CATIA Creative Conference, and that the presentation being done in Milano, Italy will be based on as well. What's nice about that, it's got links to a number of different videos that really show you each step along the way of creating a perceived quality study from start to finish in the 3D Experience CATIA V6. So that's a nice white paper to have on hand. And a lot of that is translatable to other systems, because it talks about creating a 3DCS model and your spec studies and simulation studies and that kind of thing. So as I mentioned, today's session was recorded, so you'll be receiving that recording tomorrow about midday. If you have any more questions, we'll stay on the line for a few more minutes, but we are getting very close to the top of the hour. So I'm going to close up with just a couple of closing comments, I could probably say closing one more time.
Yes.
A couple closing comments, and then I know everyone has a lot to do today, so I don't want to keep you too much longer. But we will be sticking around for probably about 10 more minutes in case you have some final questions. The email you're receiving tomorrow will come from my email address, Ben Reese, the DCS marketing team, so you can just reply to that email address with any questions you have, even if they're for Scott, and I'll make sure he gets them. So if you have any questions about the simulation, particular products, tools, workflow processes, feel free to reply to that email. Let me know, and I'll make sure you're connected with the right people. Here's a good question. How many hours did it take to get this model built as shown for visualization?
I've been asked that. I get asked that regularly. You know, there's so many things that are dependent on that. The importing and the prepping of the geometry. If I speak just about the visualization end of it, a complete car, I could probably do in less than a day. If we're going to get really detailed and add some really kind of special stuff into it, it might take 48 to 72 hours. I don't want to say that, 2 to 3 days.
So really what Scott's trying to say is, how detailed do you want your study to be? How many variant iterations do you want to be? And are you using DeltaGen, or are you using one of the other products that doesn't have an automated connection? Go on.
Then you also have, you know, your hardware dependent. Rendering times are going to really change depending on the hardware that you're using. If you're using a render farm, if you're using a laptop versus a desktop, there's a lot of issues that are dependent on that. I couldn't look at geometry and tell you exactly how long it would take you. There's so many factors that are unknown.
But as an example you gave, if you were given this model today and you have to show what we were showing today, you could do it 6 to 8 hours.
Yes.
Right? And then if you needed 15, 30 different samples of a particular area, it might take you as much as maybe 16 to 24 hours of total work.
Right.
So, you know, 2 to 3
days.
days.
Take into account rendering time. That's just the work of setting up the file, getting my materials correct. Rendering time can go through the roof, or it could be very small depending on your hardware.
Gotcha. Now, when I'm adding the styles on, where are those styles coming from? So the colors and the materials.
Is that in 3DCS or is that in a visualization tool?
Could you talk briefly about both?
Okay, so in 3DCS, we have styles. These are pre-built ones that I've made. To make a style or a material in 3DCS is fairly straightforward. We're going to right-click on styles. We're going to say Add Style Set. So for each style set, it covers all of the geometry. So if I were to switch, give you an idea here, if I were to switch to the mojito green and then the blue. So if you're going to share materials between these two style sets, they need to be copied from one into another. We can't be on the blue style set, but yet sharing materials out of another style set. All these are made per job, per material, and we make those right into our style editor. We can go further in depth on this in another lesson because there is quite a bit in there. But diffuse color, which is the basic color of the body panels of the blue, let's say, this was for the grill, so obviously it's black. And then, so we'll build up these style sets for all these particular parts, whether it be the window, the chrome, the wheels, the tires. Everything has a specific material. Now, building materials in, let's say, DeltaGen or T-Shot or Showcase, most of them come with pre-built libraries that you can at least start with one material. Let's say you'll start with a red paint, but you'll change the diffuse color to white to make a white paint. There's things like that that you could do. Once you get far enough along and more advanced in doing visualization, you'll be making all your own materials from scratch, or at least starting with a pre-baked one that might come with your visualization tool.
So basically you have a library, you can modify your library, and as you get more experience, a lot of times you're going to want to modify your library to get the colors just right, or to get them to match the ones that your actual perceived quality team is using.
Right. I have libraries for product design versus automotive design versus, let's say, furniture design. I'll have multiple libraries only because I don't want one library with 500 materials in it.
Right. Here's an important question, actually. So say you make normal 3DCS models, right? You're generating full models, not spec studies, and they can have upwards of 100 parts. So they're fairly extensive. How do you export this into RTT Delta Gen?
Oh, that part's easy because we have our exporter. So as long as you have the visualization exporter within 3DCS and the importer within Delta Gen, it's pretty much a push button transition.
Now, if you don't have that exporter importer, or you're just starting and you haven't decided to purchase anything yet, so you want to try it out, like Scott showed earlier, you can export your nominal build, which will be all 100 parts, right? And then what you do is you just export the specific ones you want to see deviated, and you can start adding those one by one back into it. So you're going to have one nominal set of data, and then you'll have a bunch of sets which are just those parts that are deviated.
Correct.
So you bring that nominal set into Delta Gen, right? If you want to do it like a manual workflow.
Yep.
And then you bring in the deviated set, and then you start a new model, you bring in the next deviated set, and you're exporting image by image by image with the deviated set.
Right, and it's really important to note here that in 3DCS, to export out your spec studies and the geometry, you're going to actually need to activate that spec study. So I'll go to hood fender max gap. That's when I will go ahead and I'll export out just that hood in the max gap position. But it's really key to make sure that you've activated the spec study that you want to export, and then export the geometry itself for that specific spec study.
And creating spec studies is very fast and very easy. If you want to see a step-by-step process flow of how to create a spec study, I believe part 1, Scott showed us a walkthrough step-by-step of how to create a spec study in 3DCS. It's very fast. Now, talking about bringing it into Delta Gen and bringing it into our high-end visualization tool, the background image. Where do I get the background image from?
Most of your visualization tools are going to come with what's called an HDRI, which is a high dynamic range image. It's set up into a dome or sometimes even as a back plate, but it provides the main portion of your lighting, and those can be purchased. There's many places online that have fantastic HDRI images. Just to note, they're not cheap.
So now, so if I wanted to make my own, you'd probably need like a specialist tool.
You would need a special camera to be able to shoot a 360-degree image, but it can be done. Definitely can be done. You can also just set up a backplate image. You can bring in your geometry and then set an image as your background. The thing to note about that is you're going to have to match your camera angle to the camera angle of your backplate. Otherwise, things look like they were just kind of laid on top of each other. So there's a little bit of work involved in that. And that's kind of more of an advanced visualization class that I'm sure we can get into. But yeah, you're going to look for an HDRI image. You'll drop that in as your environment, or sometimes in Delta Gen they're called surrounds. So you would drop that in that position and it'll create your lighting and it will create your environment that your geometry sets in.
As a note, in the survey after this, there is a spot to leave comments and requests. If you'd like to see a webinar follow-up on a specific topic of visualization, we'd be happy to show that. We can't do a complete training class or anything like that in a webinar's time frame because we only have an hour. But if there's certain topics that we can show, like a process or a walkthrough within 40 or 50 minutes, we'd be happy to do that as a follow-up webinar. I can schedule that, and I know Scott always likes answering questions and getting that stuff out there so that way he doesn't have to keep answering it, as time goes on. So there was a quick question about computer hardware requirements used with high visualization tools, and that's sort of like a slippery slope because with high-end visualization, I think one of the best ways to say it is you can never have too good of a machine.
That's absolutely true.
But when it comes to two low-quality machine, really you want to make sure you've got a good amount of RAM, you've got a dedicated graphics card, you're using probably a dual quad-core processor.
Yeah, it depends on your rendering tool. Some rendering tools are CPU heavy, some are GPU heavy.
Okay.
Some actually use a hybrid between CPU and GPU.
Oh.
Keyshot is CPU dependent. So when you're building a machine, knowing that you're going to use Keyshot as your visualization tool, you want RAM and processor, the most that your budget will allow, get the biggest and the most that you can. When you get into other ones, they're more GPU dependent. A lot of your real-time renderers, stuff like that, are GPU dependent. So it's going to be a big graphics card. As with any software, I would say contact them, see what they recommend, kind of give them a budget of what you're looking at. They can probably help steer you in the right direction. For any visualization tool, I personally wouldn't use anything less than a quad core. It's just you're going to push it far too hard.
Absolutely. Yeah, this is the requirements for doing good high-end visualization are higher than just using 3DCS because of the sheer amount of computing and processing power required in order to get all those lighting conditions and all that refraction. And because it's an accurate view of what the product is going to look like, I mean, this is all done mathematically behind the scenes. It requires a lot of processing and computing.
There'll be a bit of sticker shock when you're building a visualization machine, for sure. Yeah.
That's just, I mean, that's just given in the marketplace. As a note on that, DCS doesn't actually supply any of the visualization tools. We do have partnerships with a number of visualization companies. So, like we mentioned, DeltaGen is provided by 3DExcite. The Keyshot and VRED. VRED and Showcase are provided by Autodesk. DeltaGen is provided by 3DExcite. Yeah, and then I'll pull up Keyshot's website here, just keyshot.com, and you can go check them out. They have a handful of different packages you can kind of start with, but it's a cost-effective tool for sure. Absolutely, fantastic. All right, so we're at 8 minutes past the hour, so I'm going to close things up now. If you have any additional questions, feel free, like I said, to either note them in the survey or to reply to our follow-up email tomorrow, and we'd be happy to help you out. We're really glad everyone was able to join us today, and thank you so much for your time and sticking around. I know, Scott.
Thank you very much. Yep. And again, if you have any questions, don't hesitate to shoot an email or, whether it be to Ben or myself, and I'd be more than willing to help you out.
Great. Well, once again, thank you. And at this time, I'm going to close down the presentation and the webinar. Have a great day.
Thank you.